All right. All the work we've done in 7.1 and 7.4 will culminate in today as we solve problems involving exponents and logs. How's that for some excitement? Yes, sir. Remember, it's already Wednesday. It is hump day, and we skipped the first two humps. How about that? That's pretty good. Today is just going to be some problems we're going through, so here we go. None of this really matters. We're going to put in play stuff that we have learned. Now, first of all, recognize this as an exponential equation. That's an equal sign, and where are the unknowns? They're in the exponent, aren't they? Okay? Now, there's two ways we can solve. And you can always take the log of both sides. Okay? So one, I can take the log of both sides. Another option is same base. I can take the log of both sides, or I can do the same base. Now, if you can do the same base, you might want to, because it's always ends up being the easiest. If I can get the same base, it's easier. But if I don't see it, I take the log of both sides. I'm going to do this one both ways, okay? So let's do same base right here, okay? So 9 with a base of 3 would be 3 to the second, right? 3 to the second is 9, isn't it? But I still have 8 minus x along with it. So 3 to the second. 27 would be 3 to the third with that same base. So we're doing the same base here. Oops. That makes sense, everybody? Now, here's the cool part about same base. Once we get the same base, guess what we can do with it? We can drop it. So now, okay, now we're going to have, this is going to go, the equals just slides there. I'll distribute 16, right, minus 2x equals 3x minus 9. So if I get the same base, I can basically drop them. Now, of course, this is an equation that everybody in the room should be able to solve for, especially if you're not even looking. You're going to add 2x. Going to add 9 over here. I'm going to get 25 is equal to 5x. And I'm going to end up with x equaling 5, aren't I? Now, that was same base. Let's do log of both sides. I'll take the log of 9 raised to the 8 minus x is equal to the log of 27 raised to the x minus 3. Taking the log of both sides. Now, what is the advantage of taking the log of both sides? Well, we can bring the exponent down. So now we're going to have 8 minus x log of 9 equals x minus 3 log of 27. Again, this is the second method, or in this case up there I have labeled number 1. We did same base number 2 first. Now we're doing log of both sides. Now, log of 9 is just a number. So we're just going to divide by it. And here's where you'll need your calculator. So if someone can help me out, I need log of 27. Make sure you close your bracket. Divided by log of 9. I think it's 3/2 or 1.5. It'll probably give you 1.5. We can do fractions or 1.5. 1.5 is fine. We stay with decimal. So over here, we're going to have 8 minus x is equal to x minus 3 times 1.5. Is everybody still with me? Distribute that 1.5. I'm going to have 8 minus x equals 1.5x minus 3, negative 3 times 1.5 would be 4.5. And we're working with some decimals here. All right, I'm going to take this x, I'm going to add x to this side, I'm going to add an x, and I'm going to add 4.5 on this side. So I'm going to end up with 12.5 equals 2.5x. 12.5 equals 2.5. Of course, now what? Divide by 2.5, and guess what our x is? Whoops, oh boy. So I'm gonna divide by 2.5. Got a little glitchy there. And my x ends up being 5, the same as I solved there. So there's always 2 ways to do it. Now listen, one way doesn't always work. Which one? Same base. Sometimes they don't get the same base. But the way that will always work is what? Log of both sides. Now when you start taking log of both sides, you're going to probably get some irrationals, especially if you can't get the same base. So first thing you do when you look at a problem, you got to figure out, am I going to do log of both sides or can I get the same base? Does that make sense to everybody? Okay. All right. Note taker's good here. All right, my first question is, can I get the same base? 4 and 5, the answer would be no. Okay? So I'm going to take the log of both sides. It's the only way I can solve for this one. Now, you can start getting a little better with it, and you don't have to write so much out. So if I do take the log of both sides, I know that that x minus 1 comes out front, and I have log 4 equals log 5. Now, I kind of just skipped writing this. I skipped writing log 4 to the x minus 1 equals log 5. I just brought that x minus 1 out front when we take the log, because that's why we take the log, so we can bring that out. Has everybody got that? Remember, log of a number is just some number. So now what am I going to do? Grab your calculators and divide. So I'm down to this now. Log minus 1, x minus 1 is equal to whatever this decimal is going to be. So in fact, that becomes a calculator problem. Grab yours. It really becomes x is equal to what? Whatever log of 5 divided by log of 4. And in fact, it's not going to be equals anymore. It's going to be approximate because this is going to be an irrational. And then we need to add 1 to it to solve for x. So grab it. I assume it's like, it should be 2 point something after you plus 1. So log of 5 divided by log of 4 should be 1 point something. And then you're going to plus 1, so is it 2.16? Okay? So x would be approximately 2.16. So the top. There's always two ways to do them, right? Same base. Let's be truthful, same base is easier, okay? You get the same base, you don't have to do a bunch of stuff. It's just a little algebra. But if you don't see the same base, you can always do what? Log of both sides. Always works. You can get the same base, but if you don't see it, do the log of both sides. I'm going to give you about a 34-second head start on me. See what you can do. Some students just forego the same base, and that's fine. Just learn one way. If you just want to learn one way, then that's fine. Just take the log of both sides. This one can be done both ways. I will do it both ways. Three times 3 is 9, times 3 is 27. So in fact, this just becomes 2x equals 3. Oops, how about the other way there, bro? Divided by 2. Same base is pretty easy, that one, wasn't it? Can we do log of both sides? Certainly. I'll skip the first step. I'm going to have 2x log of 3 equals log of 27. I'm going to have 2x equals log 27 divided by log of 3. You'll grab your calculator and put that in. And then you're going to end up with 2x equals 3. And of course, x is 3 over 2. How are you feeling about that, Froggy? Questions, anyone? Everybody okay? Pretty exciting, Jess? Oh, yes, it is, isn't it? Just overall, just so much. This is almost as exciting as Monday night when we got the call that there was no school on Tuesday, wasn't it? No, that was exciting. Slatesy, how are you? Yeah. When you end the season, it's just not fun, is it? Because you've been doing it every day since November 1st or so. And you guys, that was a tough game. Long way to go. That official never should have made that call. That last call. Don't decide the game on call. All right. Can we get the same base here? I'll answer it for you. No. Okay. So what's the only way we can solve for this one? What do you think, John? The only way we can solve for this one is? Correct. Take the log of both sides. All right, see what you can do if you're playing along today. Some days are all rough. Take the log of both sides. Log 7 negative x. Log 21. Negative x comes down out front. Log 7 equals log 21 divided by log 7. So you're going to have negative x equals, in your calculator, log 21 divided by log 7. Now, so then I'm going to have to multiply by negative 1. So x is really equal to negative 1 times whatever log of 21 divided by log of 7 is. This is really on the calculator. You got it? Anybody have an approximation for me? X is what? probably gonna be negative number, isn't it? Log of 21 divided by log of 7, anyone?
Negative 1.56.
That's good enough. So log of 21 divided by log of 7 is 1.56, huh? How we doing? Is everybody okay? What are we doing? We're solving for what? Log equations and exponential equations. How can we solve for this one? Same base or log of both sides? What's the only option? All right, log of both sides, go. So x is equal to log of 15 divided by log of 2 divided by 3. I don't know, whatever, what's that number end up being? Anybody close? It's all in the calculator. Make sure you put it in right. Log of 15, hit enter, divided by log of 2, hit enter, divided by 3. Less than 2, isn't it? 1 point something.
1.3.
Approximately 1.3, what?
0 to
Good enough, that's fine. Is everybody feeling okay about these? Let's keep going. You already know those properties. Okay, we have a log equation here. If you have a log equation, okay, the first thing you want to do is get it as a single. So a single log. If it has a minus between them, we divide. If it has a plus between them, we multiply. We did that in the last quiz, remember? Step 2, write in an exponential. Step 3, solve. So in this case, step 1 is already taken care of. It is in a single log. Now I'm going to write it in exponential. Okay, so I'm ready to skip right down here. It's going to be 6 to the negative first is equal to 2x minus 1. So I'm going to write exponential, the base to that side. Six to the negative first happens to be what? 1 over 6. 1/6 is equal to 2x minus 1. Still hanging in there, everybody. How do I get rid of 1/6? Multiply by the reciprocal, which would be 6. So I gotta multiply this side by 6. 6 times 1/6 would give me 1. Distribute here, I'm gonna get 12x minus 6. I'm gonna plus 6. gonna get 7 is equal to 12x. And then, of course, I'm gonna divide by 12 to get your x equal to 7 over 12. So you're gonna write it as a single. Then you can write it in exponential. This is a log equation. Now, if it's an exponential, sometimes we want to use logs, which we just got done doing. You notice we did the first ones were all exponential. Now these are logs. Everybody okay? All right, let's try one. I'm not, okay, what's in between them? Minus. Okay? We gotta write it as 1. See what you can do, write it as 1. Write it as 1. Does my first step make sense to you? Okay, what was our second step then? Write it in exponential. So what's exponential gonna be? 4 to the first is equal to 100 over x plus 1. And we know 4 to the first is what? 4. So now you're down to solving for this. 4 is equal to 100 over x plus 1. Now, when you see something like this, everybody always, you get different things. If I have a fraction on one side, sometimes it helps me to think of a fraction on the other side. Because then if I see a fraction equal to a fraction, in your math career, you should know, a fraction equal to a fraction, what do? Cross multiply, right? 1 times 100 would be 100. Remember, that's gonna have to be distributed, so it's gonna be 4x plus 4. So from there, I think everybody can subtract 4, divide by 4, and get your x at 24. Now, what's kind of cool is we can go back and check that, which we really want to do sometimes. If I put 24 in here, okay, that would be 25 within there. If I wrote it as 1 log, it would be log base 4. This was 25 here, right? And I divide, that'd be log base 4 of 4. Is that equal to 1? Well, it certainly is, isn't it? Log base 4 of 4. So I could put 24 back in there. And we do want to check that because we don't want negative logs. Because we can't have negative logs. So if we get a negative log, then that's an extreme of a solution. We want that out of there. All right, so what did we do? We wrote it as 1. We wrote it in exponential, and then we solved, didn't we? All right, a little twist here. It's still a log. It's already written as 1. I'm going to do something with that power of 4. What would be good to do with it? Let's bring it out front. Now, what's cool about that is now I can do what with it? I can divide by it. You still in there? it in exponential. What would it be? My base 5 to the second equals x. And now I think I know what it is. What is it? X is equal to 25. How we doing? We could check this one too. It does work. Doesn't make a negative log. Questions, anyone? I had a couple more. Okay, but I'm gonna go ahead and move forward with you. We'll catch these, some of those on tomorrow. So if you can see what you can do with those problems, I would suggest trying to cement some of that in with the last 5 to 8 minutes you have left. Thank you for your time.